Let's move on to durability and fabrication. And now I'm really going to challenge Scott. So I want to hear about how you are addressing assembly of these units and concerns that might come up around, well, what happens if that hermetic seal fails? Or what happens if we don't have a durable perimeter edge seal? How long is that unit going to last? And how are these units being assembled today to mitigate that risk?
I mean, that's the $10,000 question, because so when you look back historically, what I mentioned before, people used high temperature sealing glasses, which, detempered the glass. Okay, so as you lower the melting point of these perimeter seal materials, you become more susceptible to moisture, vapor transmission, water migration through the seal. The density of the seals goes down in grams per centimeter cubed, and so as the density drops, the cohesive strength of it drops. So that's the biggest challenge, is you've got to lower the melting point so that you can, not detemper the glass, but then you've got to maintain this hermeticity, and then you've also got to maintain moisture resistance, and then also mechanical durability. Okay, so that's where we put all our effort for 3.5 years, was on that perimeter seal. Because if you can't solve that problem, then you're never going to get to a 20-year.
So thinking about, how do you think about life cycle testing or sort of accelerated weathering testing just to ensure the effectiveness?
Yeah, so we have a very large lab with a lot of environmental chambers. Okay, and I'll give you an example. So like for thermal cycling, in a traditional IG, 2188, 2189, and 2190, the ASTM standards, you cycle between minus 30C and, depending upon your level, 65C. Okay, well, what we do is we cycle from minus 70C to plus 130C. Okay, and we do it in 4 hours. Okay, so we're doing a bigger range, and we're doing it 2 to 3 times faster than the test standard. Okay, and then we do it for an extended duration. Okay, and then what we've done a lot of is combinatorial testing, where we actually soak our entire unit in 65C DI water for 10 days, take it out, put it in this minus 60, minus 70 to 130 thermal cycling, take it out, same unit, we put it in 85C, 85% humidity, and then we take it out and we do plus and minus 90 degrees C asymmetric thermal shock, where the inside of the chamber is minus 70, the outside is 20 C, and then we'll take the inside of the chamber up to 110 degrees C, and then the outside is 20. So like that's a test regimen for us.